So I'll be talking about digital heritage today and how advanced digital techniques like AR and VR bring value to the heritage sector. So first I'll give you a little bit about my background and how I got started in this field, and then I'll talk about the problem that I deal with, which is faced by the heritage sector, and how digital heritage solves this problem and the processes involved there. And then I have 3 case studies that I'll go through just to kind of give you an idea of what is being done in the sector. So to quickly give you a definition of what I mean when I say digital heritage, that is using any digital technology to record, study, or showcase heritage. So I have a background in film and I've done a little bit of graphic design as well. But in 2017, I started my master's in buildings archaeology at the University of York. Within this, I also took several digital heritage courses, which led to my training in 3D modeling and my beginnings with VR. For my dissertation, I reconstructed 2 versions of Slingsby Castle in North Yorkshire from archival evidence and created visual displays for a local exhibit, which included a few virtual reality experiences of the models. And I'll discuss this later on in one of my case studies. Outside of my training during my master's, I've also been self-teaching on skills like mobile app development with React Native and Unity for AR and game development. And I find online courses a great way to start this out and then using specific projects to develop those projects further. I began Experience Heritage in 2018, working on projects with a national trust at Nostell Priory and with the Center for the Study of Christianity and Culture in York. These required research, modeling, and photo editing as well. And since then, my projects have included Heritage Trail mobile app for the Tang Hall area in York, laser scan data processing for an archaeological site in Jersey in partnership with the University of York, and a digitization of a historic doll's house at Nostell Priory. I'm also developing an augmented reality offerings and have a few potential AR projects in the works around heritage sites in York and the UK. Within heritage interpretation and engagement, the largest problem is inaccessibility. Whether a site is a ruin, an artifact is too fragile to be touched, or parts are missing, or a site is just physically inaccessible, these factors often require audiences to use their imagination to fill in gaps based on maybe a sentence or 2 of interpretation at a site or within an exhibit. This makes it a difficult challenge to educate and engage audiences with the rich past of a structure or an artifact. And these are 2 examples. This is Slingsby Castle, which is a ruin now. It's inaccessible because it's dangerous. It hasn't been upkept, so it's not very accessible to the public. And then Skipsea Castle is now just an earthwork. It's no longer has the timber frame castle that once stood upon it. 3D modeling has taken a large step forward in archaeology and heritage and feeds into tech like augmented reality and virtual reality, helping to solve the issue of inaccessibility. 3D modeling from research, photogrammetric modeling, and structure from motion are a few ways we can construct a heritage site or object in order to place it into a digital space used to inform and engage the public. In the case of modeling the incorporeal, 3D modeling requires research. Factors such as layout, the height of a structure, or the materials that might have been used must be determined. When definite facts aren't available, sometimes you have to use comparative examples to fill in the gaps. Once enough information is gathered, 3D modeling can commence. Throughout the process of 3D modeling, several roadblocks will inevitably appear, and resolving these issues often leads to further discovery. When reconstructing something in 3D, you have to consider a lot more factors than you would if you were just maybe making a 2D sketch reconstruction. With a completed 3D model, there are many potential use cases for exhibition. For open sites with minimal interpretation, an augmented reality app might be the best solution. Visitors will be able to access this using their own personal devices that they've already usually have on them. The 3D models will display overlaid onto the current landscape, better illustrating to the visitors how the site would have once appeared. They will be able to interact with the different informational points around the site to learn more about features and the site's history. Within a museum or historic house, a VR experience might be preferred to fully immerse a visitor into the model and give them a sense of what it might have been to be there. And this is a cool picture of Sir David Attenborough using Jurassic World VR at Yorkshire Museum, and that was done by Bright White. Other opportunities include informational videos using 3D models as a part of a digitized animation or as part of an interactive game. With touchscreen displays, delicate artifacts can be better studied in 3D and from any angle and with zoom features. Sketchfab.com is a great site to go to, and if you visit there, the British Museum has a lot of their artifacts up there in 3D model, and it's a great way to inspect these artifacts from different angles that you wouldn't normally be able to do when you're looking at an exhibit behind glass. Heritage exhibits can also be made available online for users to enjoy all over the world or at a safe, socially distant space. 3D models can also be integrated into mobile apps as part of heritage trails or self-guided tours. So this is case study number 1 was Slingsby Castle. It was a Jacobean manor built on the site of a 13th century moated castle. It is currently nothing more than a ruin, as you saw earlier, and there's no plans for preservation or restoration at the moment. As I mentioned, I did this as part of my research in my master's dissertation. I reconstructed 2 versions of the structures intended for the site. One version was an early design that was never built, and the second was built but now stands in ruin. Original floor plans and other design sketches still exist in an archive and were a large part of the reconstruction process. Research on the builders, their styles, and other projects, as well as historical records of Slingsby itself, helped to fill in the gaps as I moved from these 2D aspects to a 3D model. The models were built in 3ds Max after first outlining the floor plans in AutoCAD. There were several conflicting historical records and knowledge gaps, which posed challenges to the creation of the final design. For instance, for the unbuilt design, floor plans only existed for the ground and first floors, though there was very likely at least 2 more levels intended. And as you can see from the model, I made it a 4-level structure, and that was based on comparative evidence and reasoning. For the unbuilt design, 2 historical sketches had conflicting roof lines and staircase layouts. This brought up new questions about these historical sketches, but also led me to make educated guesses in order to complete the model. In the end, because of this modeling and questioning process, we were actually able to learn a lot more about the site and its intended uses. For instance, one thing we discovered was that the unbuilt plan most likely intended to reuse parts of the medieval castle. The 3D models were used within video, 360 images, and virtual reality displays as part of a local exhibit. As the community makes the big decision whether to leave the site to continue to be reclaimed by nature or whether to have it restored, the understanding of the site's impact on the surrounding landscape provided by these visuals, and the significance of seeing it stand as more than just a withered ruin with this immersive technology will help foster interest and conversation into this debate. Case study number 2 was at Nostell Priory. And this recently restored 18th century dollhouse is now on exhibit at Nostell Priory. The curator was looking to create a supplemental video to tell the story of the doll's house as part of the exhibit. He asked if I could create an animated digital visualization that showed how the now detached doors would have slid open and how it would have looked when they were fully on and closed. Because the house is so big, it's around 2 meters in height. This was also an opportunity for people to see it at more angles than you would normally be able to in the exhibit. The models of the house and the doors were created through photogrammetry, or the lacing together of numerous photos to create a model. I worked in Metashape to create the initial model, and then MeshLab and 3ds Max to clean up the model. Finally, I animated the movement in 3ds Max and compiled the final video in Adobe Premiere. We decided to use photogrammetry rather than 3D modeling from scratch because this would allow for a more realistic texture and model. However, this added its own challenges. For instance, the dollhouse was stored in a small room, and we couldn't actually get access to some parts of the dollhouse when we were taking photographs. Because it was also fragile, we couldn't move it around. So I ended up having to completely remake the back and the roof of the dollhouse. Furthermore, photogrammetry creates large point clouds, which can significantly slow down the processing of software, which made editing a slow process. But as you reduce the points, then you lose a lot of the detail, which we didn't want. So this was a balancing act that we had to do. Not only was this a way to showcase a part of the doll's house that is no longer possible non-digitally, the 3D model could now be used in other ways in the future. For instance, we might make an augmented reality app where we place the doors back on real dollhouse. And also the model can also be used in an interactive game, and that's something that the curator is thinking about doing. Case study number 3. This is a potential project we have pitched to the Whitfield Tabernacle Trust in Bristol. They're looking to create an augmented reality mobile app to provide interpretation for a site which is being restored from a ruin. The Tabernacle is a small religious building that is tied to the founding of the Methodist Church in the UK and in the US. In 2000, it suffered damage from a fire and has stood ruined and roofless ever since. The trust has just gotten grant funding to rebuild it as part of a wider push to reinvigorate the local high street area and reinforce the historic nature of the area. However, once the structure is reconstructed, it's going to be used as a performance space, and they're not sure whether or not there'll be chance to put historical interpretation on the inside. So we provided them with an idea for an AR app, which would place a 3D model reconstruction of the original tabernacle over the current ruin and then reconstruction. We would use markerless GPS tracking to place the model so that there would be no need for a marker to be scanned on site, and that way people could also view it from any perspective. It would have a media touch points for further information in the form of audio, video, or written content. It would also allow the visitors to view the structure from different perspectives and view the interior, even if they wouldn't be able to go inside. To give further historical information, we would create several videos detailing the stories behind the site, and we also suggested including some simple games to educate and entertain children on these facts. Part of the appeal for the digital product such as this was to allow interested parties in places like the US to be able to enjoy the history of the site without actually being there. So we would include an armchair version, which would allow the AR visualization to be viewed from anywhere. In heritage, funding a project such as this can be a challenge. That's why we've broken this project up into rollout stages so that they can begin with a more simplified AR app and progress as funding becomes available. The model for this project would be built in 3ds Max using archival evidence, and from the remaining structure itself using structure from motion, which is similar to photogrammetry, but in our case, we would capture video with a drone. The model would then be placed in Unity, where we'd use AR Foundation, which allows for cross-platform development, to create the interface, set it to a GPS location, and then develop the other app pages around that. An app like this is a great solution to an historic site like this, which would otherwise have little possibility of interpretation and education, and for which bringing in new audiences is a priority. From the user's point of view, it's a simple option to gain more information about a historic site such as this that has changed drastically over the years and which will likely be inaccessible to them for many more. Nothing is required other than their own mobile devices and an internet connection. And this will be available to people all over the world. Obviously, there are many more uses and potential uses of advanced technologies within heritage, and today I've only covered areas that I work in. But as I hope you've seen from these examples, digital heritage is a varied field, and the use of advanced technologies like AR and VR help sites provide more accessibility to otherwise inaccessible heritage through engaging and immersive techniques. It is also a way to learn more about a lost or changed site and to educate audiences on incorporeal aspects of history. Thank you very much.